Friends, welcome to the study culture. Here I came with the wonderful topic building material stones video which may helpful to you, and here coming into the topic building material stone. What is stone? Stone is a natural building material that has been used for centuries in various construction applications. It is durable and versatile material with a wide range of uses from structural element to decorative finishes. The use of the stone in construction can give buildings a timeless and aesthetically pleasing appearance. Here is an introduction of the building material made from the stone. The examples of a stone constructions are Taj Mahal, Red Fort, and there is a number of temples are there. What is petrology? Petrology means here in a Greek, petra means rock, logos means science. Petrology means rock science. This is a branch of a geology which deals with the study of a rock with particular stress on their mode of the formation, composition, and uses of all types of engineering works. Rock forming minerals are there. Some are physical properties of the minerals also very important to find which the rock coming from where the rock. Okay, there are some physical properties which are very important physical properties of minerals. There are 9 physical properties are there. Note it down. Structure. Structure of the stone. Crystal system. What is the crystal system of the mineral? Color. By seeing its color, we can identify. Luster. Streak. To identify the stone by seeing its physical properties from these 9. Sixth one, hardness. Hardness of the mineral. Seventh one, specific gravity. Specific gravity of the mineral. Eighth one, cleavage. And final, fracture. What are these? Okay. Next. What is structure? Structure of the stone. It may be defined as the property which indicates the order in which the atoms of the mineral are arranged. There are some terms and some descriptions are there. Example, crystalline. Crystalline structure means when the mineral has a fine crystals packed together. When the mineral is fine crystals packed together is known as a crystalline structure. Granular structure is there. Granular structure, that is when the mineral has a cores are fine packed together. Mineral has grains which may be coarse or fine packed together. Next one, fibrous. Fibrous structure means when the mineral has a thread-like structure. When the mineral has thread-like structure. fibrous. Next, columnar. Columnar means when the mineral has a thick or thin column-like structure. Thick or thin column-like structure is known as columnar. Next one, massive. Massive structure means when the mineral has a irregular structure. Irregular structure is known as a massive property. And the final one, bladed property, when the mineral has a blade like structure. Blade like structure. This is the structure, physical property of the mineral. What is crystal system? In any mineral, there are some uh, different types of systems are there. A crystal may be defined as a regular polyhedral form bounded by smooth surface which is acquired under the action of a intermolecular forces. There are 32 classes of the crystals, but generally 6 crystal systems are there. There are crystal systems. First one, cubic system. Means cube-like structure. Like this. Like this is known as a cubic system. Another one, tetragonal system. That means this. Hexagonal, orthorhombic, monoclinic system. I will explain the differences between the cubic, tetragonal, hexagonal, orthorhombic, monoclinic and final one, triclinic system. Cubic system means its symmetry is 3 equal axes at right angles. That means these are right angles. That is known as a cubic system. Tetragonal system. What is tetragonal system means? The symmetry of 3 axes, 2 of the equal in length and 1 is perpendicular, while the third is longer or shorter and perpendicular to another one. That means in the tetragonal, two of the axes are equal and one is perpendicular to that. It may be longer or shorter. In example of the tetragonal system is zircon and rutile. Zircon, rutile are the examples of tetragonal system. Next, orthorhombic system. In orthorhombic system, the symmetry 3 axes all are the different lengths and perpendicular to each other. If we consider that A1, A2 and A3, 3 are equal, 3 are different and perpendicular to each other. In the tetragonal, A1 equal to A2 but not equal to A3. Okay. Monoclinic system. In the monoclinic system, the three axes of a different length with two of them inclined at an angle that is not 90 degrees. There are three different axes are there with different lengths. Means L is not equal to all three axes, but two of them are inclined at an angle not 90 degrees. They are two of them are not 90 degrees. Like that. Next, triclinic. Triclinic system, three axes of different lengths. That means L is not equal to A1 is not equal to A2 is not equal to A3 and all inclined at different angles. They are not same angles also. Next, hexagonal system. Hexagonal system has a four equal and horizontal axes forming a hexagonal with a vertical axis of a different lengths. Hexagonal, in the name it has a hexagonal. That means four equal horizontal axes forming a hexagonal with a vertical axis of a different lengths. Means these two are equal and these are different in lengths. Example for the hexagonal is quartz and calcite. Next, rhombohedral system. Rhombohedral system. In this symmetry, similar to the hexagonal system but with three axes of equal length and angles are not 90 degrees. In this, the angles are not equal to 90 degrees. And example is calcite and dolomite. These are the examples. Next main heading, color. What is color? Color is not constant in most of the minerals and commonly the color is due to stain or impurities of the mineral. In the mineral, the impurities causes the color, right? And also maybe due to stain. Hence the color is not reliable test. These the color is not a reliable test. Some minerals show rainbow colors either in their interior of the surface, which is known as a iridescence. Iridescence. Okay. Next. Lustrous. It is defined as the fourth main heading. Lustrous. It is defined as the appearance of the mineral in a reflected light. When the light comes and touched the mineral, the luster appearance. That means the shining part of the mineral. By seeing that part, we can expect the mineral name. We can guess the mineral name. Okay. It depends upon the amount of the reflection at the surface. That means it depends on the amount of the reflection. How much the reflection done at the surface, the luster will depends. It is independent of color of the mineral. It does not depend on the color of the mineral. It depend on the reflection of the mineral. Okay. There are some minerals are there, for examples adamantine. For the adamantine, the mineral has a luster like diamonds. Diamonds. Next, vitreous. Vitreous means broken glass. The mineral has a luster like broken glass. Resinous. Resinous means when the mineral has a luster like grease. Grease like luster called a resinous. Pearly. When the mineral has like a pears. Next, metallic. When the mineral has a luster like metal. Dull. When the mineral has no luster. This is the luster topic. Next, streak. Fifth one, streak. What is streak? Streak is defined as the color of the fine powdered mineral obtained by scratching or rubbing of the mineral on the piece of unglazed porcelain plate called streak plate. There is a one plate. There is one plate like this. This is called a unglazed porcelain plate. By rubbing this mineral on this plate, we can guess the mineral name by considering the fine powdered material. By considering what? Fine powdered color. Okay. And it is fairly constant in color and it is considered as an important property for the identification of the mineral. Okay. Next, hardness. Very, very important. Sixth one. Hardness. Hardness is defined as the resistance offered to the abrasion. It is defined as the resistance offered to abrasion. It is fairly constant for minerals and it is considered an important property for the identification of the mineral. It is determined by observing the difficulty in stretching a mineral with other ones. It is always expressed in the Mohs scale of hardness. Very, very important. It is always measured or expressed in Mohs scale of hardness. It is observed that the soft mineral like talc and gypsum can be scratched even with a fingernail. A steel knife can put apatite or orthoclase but not quartz. We can observe the hardnesses number by its name. Talc has a 1 hardness, gypsum has 2, calcite has 3, fluorite has 4, and these two may nailed with the fingernail, scratch with the fingernail. Okay, apatite, apatite 5, feldspar 6, quartz 7, topaz 8, corundum 9, and most hardened mineral is diamond that has the hardness 10. These are the 10 Mohs scale hardnesses minerals. Next, specific gravity, which also very important to identify the mineral. It is the ratio of the weight of the mineral and an equal volume of the water at 4 degree centigrade. It depends on the weight and spacing of its atoms. A mineral having a heavier or closely spaced atoms will have a high specific gravity, while a mineral having a lighter and widely spaced atoms will have a low specific gravity. It is the ratio of weight of mineral and an equal volume of water at 4 degrees centigrade, and it depends upon the weight and spacing of its atom. Depends upon weight and spacing of its atoms. The mineral having a heavier or closely spaced atoms will have a high specific gravity. The mineral which is having heavier and closely spaced atoms will have high specific gravity, and the mineral having lighter and widely spaced atoms will have low specific gravity. Okay. It is fairly constant for minerals and is considered as an important property for the identification of the mineral. All minerals have been found to be in range of 1 to 20, but most of them lie between 2 to 7. There is a specific gravity range That is 1 to 20 is the range of specific gravity. But most of them lie in between 2 to 7. Cleavage. Eighth one, cleavage. It is the tendency of a mineral to split up easily along a certain parallel planes, producing more or less smooth surface. It is considered as an important property for the identification of the mineral. When the mineral can split up with great easy and gives a smooth surface, it is a perfect, good and distinct cleavage. When the mineral does not split up evenly with the average force, it is a poor, imperfect and none of the cleavage. When it is perfect or good cleavage, the mineral can split up with easy and gives smooth surface. When it is poor or imperfect, the mineral does not split up evenly with an average force. This is cleavage. Next, final one, that is ninth one, fracture. It is the appearance of the broken surface of the mineral. It is also considered as an important property for the identification of the mineral. When conchoidal fraction means the mineral breaks up with a curved surface. Breaks up with a curved surface is known as conchoidal. Second one, even fracture means when the mineral breaks up with the almost flat and smooth surface. Almost flat and smooth surface. Third one, uneven. When the mineral breaks up with the irregular and rough surface. Irregular and rough surface. Next one, hackly. When the mineral breaks up with a irregular surface having sharp edges. Irregular surface having sharp edges. These are the physical properties of the mineral. Next, the rock cycle. How will be the rock cycle? We know the water cycle, but what is rock cycle? igneous rock changes into sedimentary rock. These will changes into metamorphic rock. These converted as a magma, and these converted as a volcanic eruption, and again igneous rock, then sedimentary, metamorphic, magma, volcanic eruption. This is the cycle of rock. Next, petrology, classification of rock. In the next video, we will discuss about the classification of rocks. And that's it for today. We'll meet again in the next topic. If you liked the video, give it a thumbs up and subscribe to my channel. If you've not yet seen my previous videos, please do check in my channel. Bye bye. Thank you for watching.